All right, I'm a bit late, but it is day 14. Well, I'm on day 14. There's a day 15, but I'm not on it yet. We have a problem. The problem is we have this grid. We're tilting the surface that this represents to the north, and all of the rocks fall to the top of the grid. We then need to work out where they sit, given that these sort of blocks actually block them as well, and then score them according to which row they are on, starting conveniently from the top, being the highest number. Ugh, how irritating. Anyway, so I've done a bit of planning. I have determined that you can conceptually, although I don't think I will implement it exactly like this, conceptually break this up into spans, and you can go through each. I think I won't actually rotate it. I think I'll try and find a. Well, I'll take a slightly different path to this. But let's say we rotated the grid by 90 degrees, and then we could work out. We could break it up into spans based on the gaps between blocks and edges, and we can work out how many rocks fit in each span. If we can do that, then we can use a formula. Well, you could just sum up all of the digits, but I happen to find that there was a formula for summing descending digits, which looks like you add the start and the end, multiply by the number and divide by 2, and it kind of plays out something like this, which I thought was interesting enough to use it, but possibly not interesting enough to be interesting. Still, maybe part 2 will become interesting. Maybe probably not. Anyway, so the job is go through each column. I'm sort of indicating that we do it from the bottom up here, but I think we will practically prefer to do it from the top down. So I'll need to sort of puzzle around on that. But let's say we were going from the top down. We go through each cell. If it's a rock, that's the O here, we add 1 to the rock number. If it's a block, we add the result of the formula based on where we are to the total. So essentially, if we take this row, then we go down, okay, 1, 1, 1, 2, we hit a block, and then we calculate based on this row. We've got 2 rocks, and we're starting at cell 4, so it's 4 plus 3. With this formula, we add that to the total, and then we should be zeroing out. Zero out the rocks here, and then we keep going down till we reach an edge where we finalize the number by adding this to the total. So reasonably straightforward. Now, an annoying quirk of the problem is that it comes in this sort of well, this is what it looks like for real. And it's not really the representation we would like. So we're going to either have to transform it into that, or we're going to have to alter the algorithm slightly. So there are a few things that we need to know. Essentially, we could create a column. I'm very zoomed in here. I don't know why. We could create a column, and then it could have something that was like add on it. And then as you go through each line top down, you could add a rock to the pile, and then you could have a calculate on the end, at which point you would know that you would know that you'd been able to break up. In fact, probably we could do this. We could do this differently. We could say sort of, I don't know, we could just say add, and then we could be adding either a dot, a rock, or a block. And then at the end, because we'll have processed the same number of things each time, we can run this calculate function on everything. This add, its job will be to essentially create maybe some sort of span object or span representation. And a span will be, in this case, let's take row 3, row 1, 2, 3 again, and its first span is going to be starting at 10, and it's going to have 1 in it. Its second span is going to be starting at 4, and it's going to have 2 in it. And all this is able to be calculated, except for the 10 and the 4, because we don't know how high it's going to be. But we could give it that information, or we could have it back calculate it in some way. Probably the most robust way of doing this would be to have it calculate based on 0 and 0, 1, 2, 3, 4, 5. 5, and then at the end, once we know how many there are in it, we can subtract the real length. This is, however, getting into the realm of things that I'm likely to make a mistake on, which I'm trying to do less of. So probably the most no, I'm going to do it anyway. See if I can. Maybe I won't learn from my mistakes today. I'm going to do it anyway. I just don't. It squeezes me out slightly to queasy. Makes me feel slightly queasy. Hard coding in the length or doing any kind of annoying transposition at the start doesn't feel nice. I don't know if that's a good decision or not. So anyway, so let's go with column representation. It's going to have in it some span, which I'm going to have be a list of tuple. No, in fact, I'm going to go with, I can't, yeah. I'm going to go with span. I'm going to have a start and a count on it. I'm going to have a list of spans, and then my calculator at the end is going to go through and run the formula with each one. So probably we can have a calculate based on a height, or let's say what do we call this? Room length. That's better. We can calculate the room length from this. So this will also need to store a room length. Okay. And then we're going to need to have a class line, calculate. I'm going to want to have a state, which is going to have columns in it. Doesn't matter really what they are, how many there are, or where they are. And then we can give it a calculate here and I think we might have like an add with an X and a Y. That will make things a bit simpler. Let's call these row and no, wait, col and row. Column comes first. Okay. That's good. Okay, now planning out. We've got span, column, state. Okay, and I'm trying to add something to my process to just increase the amount of verification I'm doing. So now a step to think about verification. Now with span, we'll be able to calculate. We will want to verify calculate, which we can definitely do. With column, we'll want to verify the adds, so which I will do. Okay, and verify then the calculate. State, I won't really need to verify anything. The others I'll be fine. Okay. All right, let's switch to the code. In fact, I'm going to pause that. I'm going to go get my laptop. Back again. Got my code. Going to open up day 14. Put the trial in. And the input in. Input's big, but not too big. Open up the code. This. Oh, my laptop's a bit slow. Oh well. Okay. Reset the timer and let's go. Oh yes, I've not got a bunch of stuff on this laptop. All right. I got that right. Looks like it. Syntax for that. Okay. All right, now we can start to check. What's going on with all my utilities here? Weird. Okay. So that should be 34. Okay. Great. Go with edge. Okay, that looks good. Let's check that's right. Okay. And let's integerize this. All right, now let's try this with another one. Let's say the one that starts at 4 and has 2 in it should be 7. It's actually 11. I knew this formula would get me into trouble. Oh, it actually doesn't start at 4. It starts at 0, 1, 2, 3, 4, 5, 6. Great. Okay. Let's remember that. Okay. That's the first one. Class column. It is a 0, right? No, it's an O. Yeah, it's one of those. Okay, that. Then that. That. There's 2, then a dot, then a 0, then a dot, then an O, then a dot, dot, hash, hash. Okay. Hash, hash, dot, dot, O, dot, O, O, O. Okay, great. This should be 34. Okay. That one should be going up by 1. If char is a O, and we take the last span, hit the last span, and we Add one to the rocks. If the character is a block, then we I'm gonna need the row here as well. Okay. Where's that? All right, fine. Okay. Then we want to append to the span where the row is row plus 1, because that's when the span starts after the block. Nothing there. Fine, 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 fine. Great. And then the calculate is simply to sum the span count event with span in subspans. With the room length, which will be what's going on here? Great. Okay, that's better. Okay, that's the column done. For the state, we're going to have columns being a list of column. Actually, I'm going to check this again with a different column, one that is slightly more complicated. Okay, so this one goes dot O dot 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 hash O dot dot O. And this one should be 7 plus 10, but it's not. Okay, great. So the span starts at 0 and gets 2 rocks, which it should not. And that span starts at 5. That span starts at 5. 0, 1, 2, 3, 4, 5, which it should start at 6 actually. 0, 1, 2, no wait, I'm doing the wrong way around. That's why. Oh my gosh, what is wrong with me today? 1 point 0 point point, point, hash, O, point, point, O. Okay, that's correct. Great. No, not that. Okay, great. Columns now, add for row character. And we're going to find the column. We go dict here. Okay. We add to that. Okay. That's good. Now, parse line, we're going to take the state and the row, which means we should then be calling state add. No. Call row char. That's weird. Is that right? 136. Okay, now this should be the right answer. Let's try it out. Great. Part two. Deforms, but not in the way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After one cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. Okay. Well, my part 1 is probably not useful at all here. Okay. Tilts the platform 4 times. Yeah, great. Okay, so north, then east. No, north, then north, west, south, east. Okay. So we move them all up, which in principle is reasonably easy to sort out. You could just write that out, really. All the information's still there. Okay, then east. Same logic, but you would need to do it with the rows. South and then west. And then we're doing a lot of times, so probably we're not going to want to calculate all of this. We'll want to work out if there's a pattern we can exploit. Which there must be, right? There's no pattern evident here, but okay, I'll come back to this later. Okay, so I'm going to take a bit of a gamble here and say there's going to be some sort of noticeable cycle which we can exploit. I'm going to essentially go so far as to do a pretty rough kind of flow through with the visualization and look at the output, and at which point I will pause and reassess. So that's what I'm going to do. I do have a little bit of work to do on the coding to just shoehorn in the spinning logic. Shouldn't be too horrible, but I definitely do need to do some verification, make sure this is right. So that's going to be key to avoid any mistakes on my behalf. Other than that, a simple matter of programming, and then we'll see if we can notice any patterns. So let's get started. My plan on the computer. Okay, reset. In fact, copy over this and start this running. Okay, great. All right, now reset the timer. I'm going to change this to be a pipe rather than a column because I think we can reuse it. Client is not running. I'm going to restart my editor. Give me a moment. Yeah, that reset the timer, but I lost some time setting up the editor anyway, so I'll count that as an even. Okay. Yes. And we'll see how we go with the rest. Okay, I'm going to add some means of keeping track of the blocks here. So with that, I'm not going for loads of efficiency here. So I may have to tweak that later. Okay, now I want to get cell. If the span start is above our current number, then the last span is our one. Otherwise, we keep going to the end. And the default is the end. Okay, and then we check if the right spans rocks minus the right spans start is greater than n, then we return, no wait, it's greater than, yeah, that, return that. Otherwise, we return this. Okay, now we're going to want to verify that for sure. And this is after the thing has happened. So this should be this. I'm running the right one, aren't I? Yep, okay. This one should be a dot. Let me just check I'm not. Yep, okay, this one should be a dot. This one should be a dot. Yeah. 0, so 0, 1, 2, 3, 4. all the way to 4 should be a dot, then 5 should be a block, then 6 should be a O, 7 should be an O, 8 should be a dot, and 9 should be a dot as well. But it's, which one isn't? Okay, so 6 is, that's wrong. Let me check which span I'm getting. Stop it. Getting the one that starts at 6, which 0, 1, 2, 3, 4, 5, 6, that's correct. And then the start is 6 and the rocks are 2. So we're getting -4 there, so that's not right. Okay, that's 1. Is 1 greater than 7? So this should actually be start minus. What's this? 0. Okay, so is 1 greater than 0? Is 1 greater than 0? Yes. So we should be getting the right outcome here. Oh, but I've broken earlier. Broken earlier now. Okay, so yeah, so we're going, every single one's breaking now. Okay. So start 0, rocks 1. Okay, that's better. Nice. Moment of surprising genius there from me. Okay, so we got that. Now we want to disentangle something. What do we? So we roll north first. Yeah, okay. So I want to, this is really add and roll north. No, what do I want? State. Yeah, okay. Add and roll north. Okay, and then I want to have a roll north as well. And with this, now this is where I can be getting myself into a bit of trouble. We want to roll. I think I'm going to visualize actually. Why isn't this doing anything? Oh, there we go. Hmm. Okay, is this right? Okay, that looks correct. Great. Oh, maybe we'll make something work here. All right. Now I've got to roll slightly tricky part, rolling east now. Now we want to go through each pipe. No, actually, we want to go through it. We want to create a new set of pipes. So in this case, we're going to have a new pipes, which is going to be a dictionary. And we're going to the room length. And we're going to go through each column in turn. And we're going to ask for its cell here. But they're not ordered. That's yeah, okay. Um, mm, mm, uh, let's go with that. Pipe, yeah, cell, and then the N is going to be new pipe N. And then we're done there, and then we visualize again. Should be rolling. I don't know if this rolls east or not. Oh, this is actually rolling west. Where is it? That's these. So have we rolled south? we've rolled, yeah, we've rolled. So this is a rotation. So we start off here and we've rotated. We've rotated really oddly. All right, let me piece this together. Okay. Visual aids. Okay, so we're starting off with this shape and we're ending up with this shape. Which I don't think we can actually do with a rotation. We've kind of mirrored it somehow. Because if we rotated it, we would be ending up with this here on here. So we've done something weird. All right, let's break this down a bit. Let's make this just one. Let's take this as this first step. And then let's build it up. Okay, so this is what we've made. We've drawn across from seemingly this line. We've got 4 here, which matches, and we've got 1 here. So we've rolled them all east, but we've got like a few more dots here for some reason. Yeah, let's try with 2. Yeah, we've rolled 2 here, dots, 4 dots, which is right, then a hash, and then we've got a bunch more for some reason. Okay, so we've rotated it and we've produced I think a correct outcome, but it's way too long and slightly too yeah, so it's been reading along here. So this first column is this row here, which is right. This column is the second, this row is the second column, so should have 2. This should have, yeah, that's right. This is right. Kind of. It's actually not right. This is the 4th. Okay. So this first one has 4 and 1. That's true. This has 2, just true. This has 3 and then an extra 1, which is great. This one has 2 on the bottom for some reason. And okay, so it's adding, it's consistently making sure that the lowest one yeah, so that's an error there. So let's try out this example. Okay, that's failing. So this logic we run through is 0. It's not a block. We start off with the last span being the one we go with. Do we hit into here? Okay, so we're breaking in there and finding the right span starting with 0, which has one rock. Why does it have one rock? It should not have one rock at all. Oh, I need to create a new pipe. Okay, so actually it's working correctly there. So there's some other issue. I'm ending up with too many pipes, which is weird. Or I think I am anyway. Mm. 19. Definitely shouldn't be 19. Oh, Oh, I'm such a fool. That's why. What a fool. Okay. And then we go all the way to the end where there are. So one, I'm missing off a whole row. Why am I missing off a row? Blocks on 8 and 9. So that one's right. Blocks on. Yeah, that looks right. Okay. So this is after we've rolled once, though. Yeah, so this is after we've rolled once. And this is after we've rolled east, allegedly east, but not really east. And we get this by taking this and then rolling that some way. So you can see we've got these right, these right, these right. That one's empty. This one should be empty. This one, it's got one there and then two there. Yeah. This one's there. This one's there. This one's there. Okay, great. And we have then rolled them which direction? We have indeed rolled them west. Good. Okay, all of that for this nonsense. Okay. Now we need to roll which direction? South. Is it going to be as simple as just doing the same thing? So this is rolling it once this way to the west, actually. So this is actually west. Now to roll it south, where do we end up after that? Okay, that looks good. It looks about right. Okay, so can we just do this a few times? Let me actually not do that. Roll south, roll east. And do we end up with the first output? Now it's actually transposed, so we'll want to rotate this some direction. Doesn't look in any way right. So we've rotated it north, west, south, east. This should be the original again. And it is. So we're rotating correctly. Well, at least we're rotating in the right. We're rotating in a way that doing it a certain number of times ends up with the right outcome. This is what we've actually got. Which is still going west. Okay, so somewhere along here we've come into an error. All right, I'm going to muddle around on this some more and then come back to you. Okay, I'll explain this later, but I think this is the answer. Yay! Okay, more later. So I'm here to explain myself again. Basically, the plan was like essentially correct. Once I worked out how to shoehorn my implementation into doing the rotation properly, which I will show you now, it turns cyclical fairly quickly. Now this is the trial. My input, of course, is significantly larger, and the cycle takes, I think, a little bit longer to properly pan out. Let's find out. Let's find out, because it will be interesting to know. Yeah. So this is the let's see if we can get this big enough. Oh, it is very big, isn't it? There we go. Yeah, see now it's turned cyclical. And so essentially the logic is if you can model out the rotation enough, at some point the thing the rotation becomes cyclical and it oscillates between a certain number of values. It's different each time. But once you notice this, you can then put it into some sort of calculation. So let me zoom back in again. No. So what it looks like for the trial is this. It's these numbers that rotates around these numbers, and then for my input, it was this longer sequence. And you just take the modulo of the sequence and add a certain offset to it, and you determine it. I didn't write any code to detect the cycles because I could see them myself and work that out. So that was the fastest way to do it. My implementation was again too complicated for me to reason about, or rather, it was the complicatedness of the solution led to some difficulty for me debugging and getting into a bit of a cycle of just sort of fiddling around with things, trying random shit, as I've called it. In fact, I think it's my ex-colleague Mary who called it that. Sometimes when you're working with people who are either students or possibly testing the limits of their ability to tolerate complexity, they can fall into a debugging technique, which is just like try a random thing. Does it work? No, try something else. So there was a bit of that, and eventually rode it back very gently by getting the visualization up and being able to see, just check the answers they went through. So visualization probably earlier would have helped me at this point. And I think there was part of my mind was, should I go with a sort of cellular automata approach, which would probably be significantly slower, but possibly efficient enough to get through to the cycle? I don't know. I mean, this is pretty fast. Like if I take out the sleeps, then and the visualization, and yeah, if we take out this as well. Yeah, it's pretty fast. So it doesn't take super long. Yeah, I'm still visualizing, aren't I? I'm not. So yeah, it's not slow. Probably faster than the Cellular Automata one, but doesn't need to be this fast. I don't really know. I suspect not. In any case, still puzzling away at the issue in my process here. Maybe some writing on that would be good. Anyway, I won't see you. Well, I will see you tomorrow, but I'll see you tomorrow for today's challenge, which looks to be okay, at least in part one. So we'll see. See you tomorrow.